Alright, so here we have another lesson on percents. So it's lesson 25 entitled A Fraction as a Percent. Our I can statement is I can write a fraction and a decimal as a percent of a whole quantity and write a percent as a whole quantity as a fraction or decimal. So what does this mean? Well, it's actually really simple. All it's saying is that I'm going from a fraction to a percent, and I'm going from a decimal to what? A percent. Alright, and it's going to say I'm doing the exact same opposite right here. It says I am going from a percent to both a fraction and a percent to a decimal. Alright, so let's continue. So here's my first one. Create two ratios that describe the picture. Well, I see I have 1, 2, 3 cars and 1, 2 trucks. What does that mean? Well, there's several ratios I can do. I can do cars to trucks. I can do trucks to cars. I could do cars to the whole number or trucks to the whole number. So let's show our first one. So let's make it cars to the whole. So I'm going to have 3 cars. And what is my whole? Well, I have 1, 2, 3, 4, 5 wholes. So that's my ratio of cars to trucks. Let's look at our next one. Well, what if I want to do trucks? Oops, I'm sorry. It's T for total. I'm sorry, not trucks. What if I wanted to do trucks to my total? Well, what would that look like? Well, that's going to be 2 over 5. 2 trucks, 5 total cars. So let's just check just to make sure. 3 to 5. So remember, I can do my ratios as both fractions and written like this. And then my trucks is going to be the exact same thing, only I have it written with those 2 dots for my ratios, 2 to 5. Alright, let's continue. So Sam says that 50% of the vehicles are cars. So looking back at this, Sam is saying 50% are cars. Give 3 different reasons or models to prove or disprove Sam's statement. Models can include tape diagrams, 10 by 10 grids, double number lines, etc. So for this example, we're going to be using double number lines, tape diagrams, and a 10 by 10 grid. So what do we start off with? Well, he's saying 50% are cars. That means half. I can easily look and see, well, I know it shouldn't be half. So how am I going to prove that? Well, first, I can make a double number line. So what I'm going to do is I'm going to set my double number line up, and then I'm just going to label it. I'm going to label it 1, 2, 3, and 1, 2, 3. And what am I going to do? Well, there were 3 cars, 2 trucks. They're 50%. That means they should be the same amount because this would be 50, this would be 50, and I know percents deal with 100, so they're going to have to add up to be 100. I see they're not the same, so they're not 50% each. Let's look at my tape diagram. Well, my tape diagram, how many parts do I have? I have 5 total parts. 1, 2, 3, 4, 5. This is a car, 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 truck, and truck. And if it's 50%, where should it be? My left side should equal the right side. However, since it's bigger here, I can see that this is going to be 20%, another 20, and another 20%, another 20, another 20. So what does that mean? It means cars equals 20, 40, 60. Cars equals 60%, and my trucks are 20, 40%. So right there, I can easily see that they're not going to be the same. I have a 60% and a 40%. And what's this last one? Well, I can create a model to show my cars and trucks. So here, I'm going to show 60%. So that means I would shade in 60 boxes. And my other side is going to be my trucks. And how do I show trucks? That's going to be 40 boxes shaded in. So all these I can see that my left side doesn't equal the right side. They're not the same amount. Let's watch a short video. Oops, I think I skipped the video. Let's watch it.
If we want to convert fractions to percentages, well, we can do that too using the method of just multiplying by 100, or we can look and see exactly what the percentage is by looking at the fraction. Let's take a look at 2 over Percentages are a great way of getting a sense of how much something is. 100%, for example, is the whole thing. 50% we all sort of have an idea of as being sort of half of whatever the thing is. But how do we actually generate percentages if we're given a decimal number? Well, the answer is pretty clear. We just have to remember to multiply the decimal number by 100, and that will give us the percent. For example, if you have sort of one whole thing, that's 1. If we multiply it by 100, we generate 100%. If we think about a half of something and we multiply it by 100 multiplied by a half is 50%. Let's take a look at some slightly less common percentages. These are decimals and I want to convert them to percentages. How do I do it? I multiply by 100. So 0.6 would actually equal, well, if I multiply by 100, that's just the act of literally taking this decimal point and moving it 2 spaces over to the right, and so I'd see 60. And so 0.6 is actually equal to 60%. A little more than half, a little more than 50%. What about 0.57? Multiplied by 100, move the decimal 2 places over to the left and to the right, and we see 57%. Closer to 50%, but a little bit more. Notice this number is closer to 0.5, but a little bit more than 0.5. What about this crazy number? Wow, that's a big thing. 0.8924. What percentage is it? I just move the decimal 2 places over. Don't be tempted to keep moving it over. We only multiply by 100, and I see 89.24%. It's okay to have a decimal point in a percentage, but we understand it's 89.24%. Finally, here's a very tiny number, 0.045. If I multiply that by 100, I move the decimal 2 places to the right, and I see 4.5%, a little bit less than 5%. Neat. So it's easy to take decimal numbers and convert them to the equivalent percentage by simply multiplying by 100, which is the same thing as the even simpler task of moving the decimal 2 spots to the right. Neat. If we want to convert fractions to percentages, well, we can do that too using the method of just multiplying by 100, or we can look and see exactly what the percentage is by looking at the fraction. Let's take a look at 2 over 25. If we take a look at 2 over 25, I notice something really neat. If I were to write this as an equivalent fraction, so not changing the value of anything, if I multiply the top and the bottom by 4, I don't change the fraction, but then look what happens. I get 8 over 100. So now it's really easy to take that quantity and multiply it by 100. If I multiply it by 100, the hundreds actually drop out, and I'm just left with 8%. So 8 over 100 is the same thing as 8%. Neat. Now, this second one, 5 over 8, that trick's not going to work too well. So I actually have to divide that thing out. So let's divide out and see what we get when we take 5 divided by 8. So put the decimal point here, and here we go. Put lots of zeros as we might need them. 8 doesn't go into 5, so I'm going to start actually up here. 50. 8 goes into 50 6 times. 8 times 6 is 48. When I subtract off, I get a 2. Bring down this 0. 8 goes into 20 twice. 8 times 2 is 16. I subtract off, I get a 4. Bring down an extra 0. 8 goes into 40 5 times. 5 times 8 is 40. I get a remainder of 0, so I'm done. Phew! But now I see that this is equivalent to the decimal 0.625. How do I convert that to a percent? No problem at all. I just multiply by 100, move the decimal 2 over, and I see 62.5%. So there's the percent for 5/8. Neat.
You can decide which one's easiest for you. One is if I have a fraction, how do I get that bottom number, my denominator, to become a 100? And then whatever I do to the bottom, I have to do to the top. My other method is I divide. So remember that fraction bar is like a division sign. So I can do 2 divided by 25. They'll both give me that exact same answer. So whichever method is easiest for you is what you can use. And then I move that decimal spot 2 points over, and I get 8%. When I have a denominator of 100, that's my fraction, or the numerator is my percent from the fraction. So they both will give you that 8%. All right, let's go on to our next problem. So how is the fraction of cars related to percents? Well, I know my fraction is 3/5. How can I get that 3/5 to have a 100 as a denominator? Well, I'm going to do this. I'm going to multiply by 20. So I also have to multiply my numerator by 20. So, since my percents are of 100, the two are equivalent. So here I have an equivalent fraction, and I can easily see how this 60 is my 60% of cars. Use the model now to prove that fractions and percents are equivalent. Well, the model I'm going to use is going to be a double number line, or it looks similar to a tape diagram. It's going to be the exact same purpose. What I need to do is I need to label my top parts and the bottom parts. So let's reset that. My pen's being a little weird today. So what do I need to do? Well, this top part will be what? That's going to be my percents. So you can see I have 5 parts, so each part's going to be 20%, so 20, 40, 60, 80, 100. The bottom part's going to be my total number of cars, so this would be total number of vehicles, so 1, 2, 3, 4, 5. So let's label them. Now, how do I know they're the same? Well, my fraction of cars to total is 3/5. My percent is 60%, as we saw up here. So how do I know they're the same? Well, they're the same spot on my double number line, right there. So now let's go to our bottom problem. What other fractions or decimals can represent 60%? Well, I know 3/5 I'm starting with. What's equivalent to 3/5? Well, 2/10. I multiply by 2. But I can also find other ones. I can multiply by 3. I can multiply by 4. 3 times 4 is 12. 5 times 4 is 20. Can also make it 15 by multiplying by 5. Any of those are equivalent. I have many more I can write. However, with my decimals, there's really only one way. It's this 0.6. So how did I get that? Well, several ways. One way is I did 3 divided by 5, and I see I get 0.6. So that's one way. Alright, let's keep going on to our next problem. Survey was taken that asked participants whether or not they are happy with their job. An overall score was given. 300 of the participants were unhappy, while 700 of the participants were happy with their job. What fraction and percent were happy with their job, and what percent were unhappy with their job? Well, my fraction for happy is going to start out with how many people? 300 over my total. So there's a total of 1,000. 300, 700. That equals 1,000. So my fraction for my unhappy will be the same. 700 over 1,000. So now, what do we need to do next? We need to change that to a percent. How do I do that? Well, my easiest way is I need to make my denominator 100. So what can I do? Well, I can divide by 10. I can take off a 0 when I divide by 10. And that gives me my percent right on top, that 30%. I can do the same thing over here. Divide by 10. Divide by 10. Those zeros will cancel out. I'm left with 70%. So there's my fractions. There is my percent. Now I need to make a model. So how can I make this model? Man, my pen's just not going to cooperate today. My model can look like this. Same thing that I did. I have percents on the top, and then my numbers on the bottom. And let's look. 300 is right where 30% is. 700 people is right where 70% is. So here's a model that justifies or shows how I know my answer is correct. Alright, let's watch our next video.
Okay, let's take a look at an application where percentages naturally arise. So here's an interesting story about a student, Carl, who dyed 3/20 of his hair purple to play an eggplant in a play. And I'm sure it was a brilliant performance. But here's the question. About what percent of Carl's hair is now purple? Well, we'd have to figure out what percent 3/20 is. So 3/20, actually there's a neat trick I can do here, and the neat trick would be to multiply the top and the bottom by 5. It doesn't change the fraction, it's equivalent to the original 3/20, but now the bottom, top is 15, but the bottom is 100. And so, if I want to convert that to a percentage, all I've got to do is go off here and multiply by 100. But that's great, because this reduces down really nicely to just 15. And so I come up here and say this is 15%. So 15% of Carl's hair is purple due to an eggplant condition. Neat. Anyway, hope you have fun with percents. They're a great way of measuring how much we have of something or how little we have. I'll see you soon.
Our next problem. Okay, so we have this person called Renita. She claims that a score of 80% means that she answered 4 out of every 5 problems correctly, or 4/5. She drew the following picture to support her claim. So remember, a fraction is parts over whole. So let's check it out. She has 1, 2, 3, 4, 5 rows. And how many of those rows did she shade it in? Well, she shaded in 4 of them. So here I have 4 parts out of 5. So let's see. Is she correct? Well, my answer is yes, she is correct. How do I know that? Well, I know that because 4/5 is what? It equals 40 over 50. All I did was I multiplied by 10. What did I do next? Well, remember, in percents, I always want that bottom number to be a 100. So it's 80 over 100. I multiply it by 2. And then what do I get? All I need to do is I just add that percent sign. So here, I multiplied by 10. Then I multiplied by 2. And all I did here was I added that percent sign. Now there's an easier way Renita could have shown us. What is that? Well, this model is kind of weird. I've never seen a 20 by 5 model. So what we probably want to do is I probably want to change it to a 10 by 10 grid. So let's see if we can fix that for her. So she says 80% is 4/5, which she is correct. So I'm going to shade in 4/5, or as I know it's now, 80%. So 8 of my boxes, or 8 columns, I'm sorry. So this model would probably be easier for people to look at and say, hey, that makes sense. However, her model is correct as well. All right, let's go into our next one. So here I have a picture. I already did a tape diagram or a double number line for you. Your numbers on top, percents on the bottom. 80% now is what fraction of the whole quantity? So I'm going to look at my 80%. I'm going to look at its number. Well, I see that it's 4 over, so this is my parts. I've gone 1, 2, 3, 4 parts over. My whole is what? The whole is the whole entire length. How long is that? Well, that's 5. However, there's also another way I can write this fraction since it says not simplified. I can also say that it is what? 80 out of 100. I can use these bottom numbers to also write a fraction. So here I took 80. What's the length of the whole? The length of the whole is 100. If I wanted to simplify, I can just use these numbers up top. 4 out of 5. And I see there's nothing I can divide by in either case. So here's 2 possible fractions to describe my whole quantity. Remember, whole quantity means that whole entire length. Alright, so let's use the same diagram up at the top to now solve our next question. 1/5 is what percent of the whole quantity? Well, now it's asking me for what? It's asking me for this part, a percent. So I need to get that denominator to 100. So what can I do? Well, I can multiply by 20. If I multiply by 20, that becomes 100, and this becomes 20. So now what is that as a percent? Well, all I do is I just add a percent sign to that numerator. Alright, so let's look at our next one now. 50% is what fraction of the whole? Well, 50% isn't on here, but I should know it's right here, right in the middle of 40 and 60. So what number would be right above it? Well, this is right in the middle of 40 and 60, so this is going to be right in the middle of 2 and 3 for 2.5. Another way I could have gotten that is I could say, well, 50 out of 100, so here's my percent as a fraction, and what is that going to equal? Well, I need an equivalent fraction, and I know the whole entire length is 5. So I can ask myself, how do I get from 100 to 50? Well, I divided, I'm actually going to change colors for that. I divided by 20. So I can do the same thing here. I divide by 20. Either way, I see that I get that 2.5, that 2 and 5/10. Alright, last one is what percent of the whole quantity? So I have a typo here. I should have written it better. 1 is what percent of the whole quantity? That makes it seem like I'm asking for this right here. I was actually asking for this whole quantity. This whole entire thing. What is that? Well, that's going to be 100%. Alright, so sorry about that one. Let's go on to our next problem now. Maria completed 3/4 of her workday. Create a model that represents the percent of the workday Maria has worked. Well, I'm going to start with what? Just because this is the way I've been doing them, I'm just going to make a tape diagram that I'm also kind of using as that double number line, since I have numbers on the top and on the bottom. So on the bottom, I'm just going to make it percents, 0%. The end will be 100%. It's going to be on the top. Well, this is 0, and I'm saying 3/4. So that means I have 4 parts for my whole. So it's going to be 1, 2, 3, 4. Now I can easily figure out, well, what is 1 part out of 4? Well, that's 25%. What is 2 parts out of 4? Well, that's 50%. And then I can see I'm counting by 25, so this 3/4 will be 75% for my model. So let's look at one that's just a little bit more nicer that I made. So now what can we do? Well, I can look and I can see, well, look at that. There's my 75%. All right, let's take a little break. So now, let's look at this next question. What percent of her work does she have left? Well, the blue boxes are how much she's done. So what is my white box representing? Well, this white box is how much she has left to do. And I can see that's 1/4. Or I can also see it's from 75 to 100, so that's 25%. So she has 25% of her work left to do. So let's look at my last question. It's asking to prove. So how does the model prove my answer is correct? The model shows that 3/4, so 3/4 is equal to 75%. The 1/4 she has left, so from here to here, is the same as 25% from here to here. Alright, let's go on to our next problem. Matthew completed 5/8 of his workday. What decimal would also describe the portion of the workday he has finished? Well, remember, 5/8, I can think of this fraction bar as a division sign. So that's going to be 5 divided by 8. And what does that equal? Well, let's show us. So this is 5 divided by 8. I'm just going to put a decimal here and just a whole lot of zeros. 8 goes into 5 0 times. Bring that decimal up. 8 goes into 50 6 times. I'm going to have a leftover of 2. 8 goes into 20 2 times. I'm going to have a leftover of 4. And it goes in 5 times. Alright, so let's check. Yeah, so that is how we got that 6.25. So now let's look at our next problem. How can I use the decimal to get the percent of the workday Matthew has completed? Well, this is going to be really easy. 0.625, what we say is that is 625 thousandths. So when I actually say it out, 625 thousandths, it's really easy to write as a decimal. My 625 goes on the top, and this word lets me know what is my denominator. It's thousandths, so it'll be over 1,000. Now all I have to do is I just have to make my denominator 100. How am I going to do that? Easy. I'm going to divide by 10 to give me 100. And I'm going to divide by 10. When I divide by 10, I just take this decimal and I move from one spot over. So there I go. Now once I have that part, it's really easy because all I do to get my percent is I take that and I just add a percent sign. So 62.5%. Alright, so now let's look at this. Complete the conversions from fractions to decimals. Well, I'm just going to do my fractions first. This is going to be 35 over 100, which will simplify by dividing by what? Dividing by 5. Okay, let's look at my next one. I'm going to just put this over what? 32.5 over 100. And since I normally don't want decimals, my fractions, I'll multiply by 10. And it's going to give me this for my answer. 325, or 32.5 over 5. And if I multiply by 10, that would give me 325 over 1,000. Okay, my last one, I'm going to take this percent, just put over 100 again like here. If I wanted to get rid of that decimal, I just multiply by 10. Alright, now let's do our next easy one. How do I get from here to a decimal? Well, all I do is I move that decimal spot 1, 2 spots over. Alright, let's do our next easy ones, these percents. How do I get from here to percents? Well, that's easy. What do you notice? My decimal goes 1, 2 over this way. 1, 2 over, and I add the percent. Same thing here, decimal moves over to the right 1, 2 times. Alright, so now we're to our slightly harder ones, but they're still not difficult. I'm going to make this as a decimal. So what do? Well, I'm going to write my very first one, this 1/8, I'm going to do 1 divided by 8. Just add that decimal and a whole lot of zeros behind it. 8 goes into 1 0 times, add that decimal once, going to get a 2, goes in twice, going to get a 4, bring down that 0, goes in 5 times with no remainder. So what is it as a decimal? It's going to be 0.125. Then how I make that a percent? Same way I did with these. So let's do method number 2 for this one. So I have what? 2 25ths. And how can I make it a decimal? Well, I'm going to change it to a percent first. So percent means my numerator should be 100. How do I get from here to here? Well, I multiplied by 4. So what do I need to do to this top part? This exact same thing, multiply by 4. Remember, it's the exact same thing as a ratio table. 2 to 25. And I'm going to 100. How do I get from here to here? Multiply by 4. Multiply by 4. So that's going to be 8. So now, how do I get this to become a percent? Well, it's over 100, so all I do is I add that percent sign. Now, how do I get this 8% to become a decimal? Well, I take my decimal and I move it 1, 2 spots over. I add that 0 as a placeholder, and I see it's going to be 0.8. Alright. Now, here's our last problem before your exit ticket. It says choose one of the rows from the conversion table. So this is my conversion table. I'm converting from fraction to decimal. Choose one of the rows from the conversion table in exercise 6 and use the models to prove your answers. So I'm just going to pick a row. For myself, I think it's going to be easiest if I use this right here. So let's check. 7/20 equals what is a fraction with 100? Well, I multiplied by 5, so I'm going to multiply by 5. So I need to shade 35 parts in. So that's going to be 3 rows, 10, 20, 30, and 1, 2, 3, 4, 5. So here I shaded 35 parts out of 100, which is 35%, and I see that they are equivalent, the same. Alright, let's look at our lesson summary. So fractions, decimals, and percentages are all related. To change a fraction to a percentage, you can scale up, so I can go up, or I can scale down, so that my denominator is 100. So here's an example. I have what? 9/20, and if I want to change it to percent, it says I can scale up or down. I need to scale up because I need to make this number bigger. I need to go up. So how do I get from 20 to 100? Well, I multiply by 5, and whenever I do to my denominator, I have to do to that numerator. So I get 45 over 100, then all I have to do is add that percentage sign. Alright, let's look at our second part of our lesson summary. There may be times when it's more beneficial or easier to convert a fraction to a percent by first writing the fraction decimal form. So here, I'm going to get it to a percent. I just do 5 divided by 8. Why do you think this might be easier? Well, it might be easier because this is going to be difficult. 5 over 8, what is an equivalent fraction with 100 denominator? I don't know how I multiply anything to get 8 into 100. If I do 8 times 10, it's going to give me 80. If I do 8 times 13, what is that going to give me? Well, that's going to give me 13, 8, 4, carry the 2. That's 104. It's really close to 100. It's not the answer I'm looking for. It has to be exactly 100. So that's why it's sometimes easier to change it to a decimal first. Alright, let's go on to our exit ticket. Alright, your exit ticket for problem number 1. Convert 0.3 or 3/10 to a fraction and a percent. Number 2, convert 9% to a fraction and a decimal. And number 3, convert 3/8 to a decimal and a percent. Alright, when you are finished, please go to Khan Academy. You're going to do one lesson, just one today. Then when you're done, you may play math games. Alright, good luck, have fun.